We have been able to witness hitherto unimaginable and enthralling images of the universe since the launch of the James Webb Space Telescope. It has even provided a novel viewpoint on the heavenly bodies within our solar system. Even on Titan, Saturn's moon, we were able to see clouds, albeit methane-based ones, but nonetheless cool. Furthermore, we have found potential evidence of life on an exoplanet that is just 124 light-years away from Earth. Yes, we are talking about this on a cosmic time scale, which is why I mention the distance as just 124 light-years. The discovery of extraterrestrial life is expected to occur soon, according to scientists. Let's examine how the cosmic time machine is raising serious concerns in the scientific community before getting into that. It's probable that you've heard about the ancient galaxies that the telescope discovered that defied accepted cosmology. It is difficult to believe that the gloomy ages were indeed that gloomy because these galaxies are so old that they appear to have formed a few 100 million years after the Big Bang. The oldest galaxy at the moment is Macy's galaxy, although it appears that the telescope has discovered other galaxy candidates that may be older. We have no idea what the telescope may discover next, but it recently captured an image that added even more mystery to the biggest enigma in cosmology. It's true that new James Webb photos point to problems with our comprehension of the universe. Furthermore, new physics might be required to explain the universe if the outcome is accurate. And the picture that did it is this one. You are observing the motion of NGC 5584, a spiral galaxy located 75 million light-years distant through the pulse of its stars. This implies that the universe is expanding more quickly than predicted by the dominant theory of astronomy. The standard model of cosmology, which explains how the universe has changed since the earliest moments after the Big Bang, is a highly regarded hypothesis that is at odds with the observation. What exactly is the image stirring up in our science, then? One of the key variables for comprehending the universe's evolution and eventual fate is the rate of expansion of the universe, or the Hubble constant. Envision the universe as a large balloon that is expanding with time. Similar to a unique number that indicates how quickly a balloon is inflating, the Hubble constant. Scientists have been attempting to measure this quantity using several techniques lately. One of the primary methods for doing so is using distance indicators. Consider yourself attempting to gauge the speed of a car that is too far away for you to see on its speedometer. Rather, you focus on how fast it is approaching you. In a similar vein, astronomers study celestial bodies that are much larger than our Sun, known as supernovae or supermassive stars. These are similar to cosmic pinpoints in space. By telling us how quickly they are accelerating away from us, they provide information on the rate at which the universe is expanding. 2. Cosmic afterglow. Another method is to travel back in time, much like in a movie, to the universe's inception. Like an echo of the universe's creation, scientists can examine the afterglow of the Big Bang. They can determine the Hubble constant using the universe's early conditions by looking at this afterglow. The issue is that different answers are obtained for the Hubble constant when scientists employ these two approaches independently. Scientists are attempting to determine why there is a discrepancy between these methods, which they have named the Hubble tension. Some of the greatest observational evidence for this stress may now be examined and refined thanks to new capabilities offered by NASA's James Webb Space Telescope. Thus, the telescope is pointed towards Cepheid variables, which are unique stars in space. These stars resemble incredibly bright space beacons, but there's a catch. Like trying to read a sign that's hazy due of surrounding objects, Astronomers occasionally spot additional stars adjacent to these stars while using ground-based telescopes or even the Hubble Space Telescope to study these stars. Because of Webb's exceptional infrared vision, scientists can see the Chephiid stars more clearly and avoid being misled by neighboring stars by looking through cosmic dust. The earlier Hubble Space Telescope observations were accurate, although being noisier, as Webb's observations showed. This indicates that the data obtained by both telescopes on the Hubble constant are consistent. But here's the tough bit. The cosmos appears to be growing far more quickly than predicted by science, according to its newborn image, the cosmic microwave background. Thus, the Hubble tension issue is still present. And with that, here's a crucial question to ask. What are we missing? We have to travel back in time to discover the solution. Shortly after the James Webb Space Telescope started returning images of planets and nebulae from deep space last year, astronomers were faced with an unsettling truth. Something didn't quite fit with their pre-existing understanding of the universe, despite being mesmerized by the spectacle. Now, several months' worth of data from the telescope suggest an unsettling conclusion. We may need to reconsider some of the basic assumptions that guide our understanding of the universe's creation and development. There is a set and exact sequence of events that followed the Big Bang, according to the conventional model, which forms the basis of almost all research in the field. Initially, denser patches in the cooling cosmic gas were drawn together by gravity, and these regions developed into stars and black holes. The stars were then drawn together into galaxies by the force of gravity. However, Webb's data revealed an unexpected turn in this cosmic story. It revealed the existence of extraordinarily massive galaxies that appear to form at a startlingly fast rate, confounding the mainstream model's suggested timelines. This result wasn't a little inconsistency, and to exacerbate the situation, the puzzle around the Hubble tension remained unanswered. Scientists first thought that as data grew more precise and observations increased, these differences would be reconciled. Not only has that not occurred, but the differences have become much more accurate, and the latest information from Webb has made matters worse. This pattern points to a problem with the model rather than the data. The knowledge that, during the previous 50 years, the cosmic model has undergone numerous patches and revisions to better fit the most recent evidence adds to the uneasiness. These updates seem like a succession of neatly tailored adjustments, even though they may have been necessary and scientifically justified given the existing challenges. Astronomers and physicists are beginning to suspect that something may be seriously off. The expansion of the cosmos, a finding made by Edwin Hubble in the 1920s, is the source of the standard model of cosmology, which is a monument to human intellectual achievement. Yes, Edwin Hubble presented the first observational proof of the universe's limited age in 1929. He found that a galaxy appears to be vanishing into space more quickly the further away it is from us, using the greatest telescope available at the time. Still, there's nothing fundamentally strange about these basic model features. Researchers frequently find strong indirect evidence for concepts like hyperdense singularities inside black holes, which are invisible to the human eye. However, you can't blame people for beginning to question whether the standard model is flawed and whether it's time for us to make a radical break from it in light of Webb's confusing data regarding galaxy formation and the growing issue with the Hubble constant. This may even mean rethinking our understanding of the fundamental elements of the universe, including the nature of space and time. We can assume that any scientific revolution of the kind we are envisioning will have similar effects on our perception of ourselves. We will have to wait and see what the James Webb Space Telescope does going forward. How do you feel? Is it necessary to make changes to the Big Bang Theory, or should we create a new one entirely? Please let me know by leaving a comment. I appreciate you watching, and please remember to subscribe.